Okay, my picture's not so beautiful, but this was something I did kind of late on Wednesday. Maybe not everybody was here. Um, this picture, this is supposed to be a squared off, so this would kind of come straight down like that. But they asked you to do perimeter of this, or at least know how to. And so the problem was that both this measurement and this measurement were not included. And so somehow you had to figure it. So to do perimeter, you'd have the 6, you'd have the 18, you'd have the 20 and the 8. But then what about these two? They were part of the perimeter. So one cute thing they showed, and I watched one of the videos, was that this measurement here is 20. And so because everything was squared off, and let me use a different color, that meant that if you added this one and this one, you would get 20. And so is it clear what this measurement has to be then? The total is 20, but this piece, see, this piece is the same. 6 up here is the same as 6 here. So if this is 6 and the total is 20, this has to be 14?
Right.
Right. And then the other part was this measurement, the vertical measurement is 18. So that this measurement and this measurement have to total 18. So if all of this is 18 and we already know this much is 8, that forces this to be 10. So you don't have to stare at this until you're clear about it. But once you're clear about it, then you can add up all the different pieces that make up the perimeter. So I wanted to be sure. And it's all about this one and this one, because this one is equal to this dotted. This total has to be 20 according to this. And so so if you didn't have either one, if you added this one and this one, you'd know you have to add 20. So there's actually 2 20s and so on. The other problem that some people had trouble with was this one. This was in 8.1 and they wanted the perimeter. Now, some of the measurements were really obvious. This one was 8, and then this one would be 8. Okay. This one is 2. So we're all set on that. But the trouble was, how do you calculate the half circle and how do you calculate the slanted line here? So I'm going to do the half circle first. And the formula we had was circumference equals pi times diameter. And if you look carefully at this picture, this measurement with a dotted line is 7, but this one, the other dotted line is also 7. I kind of wish everybody'd come on time because I keep having to stop. So if this is 7, that's the diameter. And so if we continued with this formula, this would be 3.14 times 7. Now to save time, I'm just going to do this. 21.98. Okay, so if we had a full circle, it would be 21.98 that we would do it. But because it was a half circle, you're going to have to divide it by 2 because we only have half of this circle. So this is 10.99. So that's exactly half. And so this measurement right here has to be 10.99. So I went with a full circle. I got the answer. And then I said, oh, it's only half. And so I divided by 2. Now, this part here, the triangle on the left, is also interesting because it's relying on things we did earlier. And so if you see, this was a 90-degree angle. This one was 2, and this one was 7. I'm going to come bring it back so you can see that. And so what we're missing is this. One more. So this is the Pythagorean theorem. A squared plus B squared equals C squared. And C is always the longest side, which is what, in this case, if you had to label it with the letters, it would be the C. It's the one opposite the right angle, but it's clearly the longest. So you would say 2 squared and 7 squared is the missing side, C squared. Order of operation, you do powers. 2 squared is 4, 7 squared is 49. That is equal to C squared. This and this make 53. So C squared, which we don't want C squared, we want C, but C squared is 53. So C is the square root of 53. Now, this is nothing you want to do by hand, although, let's see, that's what I'm getting, 7.28. That's the approximate measurement of the missing side, and I used a calculator to square root. It's clearly more than 7 because the square root of 49 is 7. This is a higher number, so it's more than 7. And so back to the original problem, this was 7.28. And as it turned out, I would add up all of those numbers, the 10.99, the 8, the 7 point that, but then it says round it to 1 decimal place. So I would just add them all up and then round the final answer. Rounding early in the problem, like rounding it right now could be off by like 1 little bit. And so you're best to leave it a little bit further out than 1 decimal place. And then you're safer that when it's rounded, it will be exactly on target. Any questions about that? So cute, using all kinds of things we've learned before. Now, I'm going to go. Are there other questions we can look at? I'm going over to, let's see. I'm going over to our homework, and then eventually I'll start that new material. So is there anything specific in the homework that I could do right this minute? And that would be 8.1 or 8.2?
All of it. No, I'm just kidding.
He's back.
Yeah.
Well, now, could you narrow it down for me? There must be something that's worse than the others.
Yeah, let me look.
I have one.
Anybody have something ready?
It is the same type of problem you just did, but it was the area.
I was going to do that next, by the way. That's why I made the picture nice and big so we could see it.
The one you had just did, okay, never mind. So we just add all of the sides, including the 2 7s in the middle?
No, perimeter means the fence around the edge.
Okay.
So the 7s don't come in, they're inside.
Okay, thank you.
Like you wouldn't put a fence inside the middle of your house. Probably. But you might put it around the edge, you see? I'm going to look at this question. This was the one. Suppose a rectangle has a perimeter of 12 inches. If the length and width are whole numbers, give some possible answers. So we were discussing this, and one answer would be 4, and the other would be 2. And 4 and 2 is 6. And then double that, because you have 2 sides on either way, opposite. That should do it. And those are the answers. Did they want the smaller one first or some stupid thing like that? Unlimited number of temps. They said it was correct. Isn't that odd? I don't know what to say about that. Okay. Let's leave this page.
It's a never-ending mystery.
It's a never-ending mystery. We just have to be not sweat the small stuff. That's what I can tell. Okay. This is 8.2, and let's just look at it without doing all the number crunching, but make sure we understand. The minute they say area, the formulas are different. So it's really the length times the width, and with a square, it would be 11 over here. So it's 11 times 11, and that answer is 121 square miles. And somebody's come in late. Let me see.
Could you look at number 8 on 8.2 when
Yeah,
you have a chance? Thank you.
yeah, let's do that. Let me see if I've got it. And share this one. I want to make sure it's this. Okay. Yeah. Okay. So I think we went through all the questions. Basically, this boils down to a rectangle because the little triangle on the left could be moved over to the little triangle on the right, and then it would be 8 by 4, which is 32. And again, they put in the unit for you, square yards.
This is the one I had a problem with.
Yeah, this one here, there's 2 rectangles, and I want to draw a line. Can you see my marker?
Yes.
Straight across. I want to draw that. And so the top one is basically 11 by 7. And 11 times 7 is 77. So I would write that down. Okay, so that's the top one. The bottom one is 31 by 7. So I would multiply that out. In some ways, this was easier. 31 times 7 is 217. And the top kind of vertical one is 11 by 7, which is 77. Just add the 2. 217 and 77. Does that work?
How do you get the 7 over there?
Which 7?
Under the 11 yards.
Yeah, they're telling you it's 7 across and 11 down.
Okay.
So that's the full measurement of that rectangle, 7 by 11. How's that?
Well, the sides that are not marked, so I see that's a 7 equal to the side on
It
the.
doesn't matter because all you need is one length and one width.
Okay.
And so, and the reason is the fact that this is the left side is 11, the right side is also 11.
Okay, right, yes.
But all you need is one of the lengths and one of the widths. And so we actually have it with having a 7 and an 11.
Okay, I see.
Everything we need to isolate that and call it 77.
Okay.
And the same is true with the bottom one. We have the horizontal one, which is 31, and the vertical one, which is 7, and it's basically the product of those two. And we don't need the other sides. We need
Okay, I
them
see.
for perimeter, but not for area. So this is
Great.
actually easier, in my opinion. What do you think? Did you get it?
Yeah, that makes sense. Thank you.
Okay. So this one here, area is pi r squared. The radius is marked as 9. So the first thing you would do is the radius has to be squared. 9 times 9 is 81. And then you multiply by pi, which is 3.14, and that answer would go here. So it's pi r squared. You should have a page with all the area formulas and a page with all the perimeter formulas, so you don't have to remember well.
So that was 3.14 times the area.
Times the area,
Or
0.14 times r squared, which
Okay.
has been, because remember you have to do squaring first.
yeah,
That would be 81.
81. Okay.
Yeah.
Thank you.
Yeah, we've got this beauty. And I think it's almost the same stupid, that they changed the measurements on me.
Yeah.
So I'm going to draw it on my paper really fast and then bring you back to the paper. Let's see, I've got a 3 here, I've got a 4 here, I've got a 7 here. All right, paper it is. We're gonna do area. Share. There it is, beautiful. I'm not so good lately. So to do area, the easiest one to do is right here. It's this rectangle. And it's 4 vertically and 7 horizontally. So area length times width would be 7 times 4. I'm just going to put it right in here. 28, I don't remember what the unit was, but we'll figure that out in a minute. So 7 times 4 is 28. That's this. Let's do the half circle. Area is pi r squared. So if this unit is 4, then this whole thing would be 4. But the formula calls for the radius, and the radius basically is 2. So remember, this whole thing going through the center is 4, that's the diameter. The radius is 2. So our formula would be this. The radius is 2, that would be 2 squared. So you have to square first. So 2 squared is 4, multiplied by 3.14. That's 12.14, 16, 56. Huh? Now, let's think about this. Don't be too excited that you have an answer.
So the radius is half of the area, pretty much.
The radius is half of the diameter.
Diameter, I'm sorry.
Correctamundo. So then this is a full circle and we only have a half. So we want to divide this by 2, and this would give us 6.28. It's the half circle. And, you know, we almost got so happy with ourselves for following this correctly. But then you had to look back at your picture and say, I only have half. So I have this number. Now, the final one is the triangle. This was a 90-degree angle because this was a 90-degree angle. And the formula for that would be area is 1/2 the base times the height. And so you have all your formulas listed. You go find your formula. I'm not expecting you to memorize every last one of these, although many of them make sense. And so that would be, the area would be 1/2. I'm going to call the base 3 and the height 4. So 3 times 4 is 12, half of 12 is 6. Again, I use, remember I told you last time, sometimes I use commutative and associative because I thought it was easier. Instead of taking half of 3, which is 1.5, I took 3 times 4 is 12, half of 12 is 6. So this much here is 6. So I've got 6, a 28, and the weird one, 6.28. I would add them up and I would then round it. I can't remember what the last time they wanted it to 1 decimal place. So just add them up and then make sure the rounding is correct. Before I leave this page, does anybody have a comment?
I'd like to mention that it seems they don't teach this exactly in the book. They just say, do this problem.
I know it.
And that's
I
the problem with
agree.
that.
That's really annoying, isn't it? And the other thing is, I really think geometry, as you visualize it, makes a lot of sense. I think this triangle looks like half a rectangle. That's all I'm going to say, doesn't it? Which helps you remember that there's a half involved. You know? And
Yeah.
I think it's visual. I think it's there.
So one more time. 6, so it's gonna be 6 plus the 28, and then the sum of 3.14. What was that last one?
This one, it's 6.28. In other words, it was the formula for the full circle,
Okay,
which we got 12.56.
yeah,
But then we looked at our picture and said, doggone, it's only half a circle. So we only have half the area.
got it.
And so we said, that's it. Okay, I'm going back to the,
The easier way that I found, when you write out the formula, is to put the number under each formula, like A equals, and then what the pi is,
well, that's
and
kind
then
of.
next to that.
You mean I didn't do this?
No, like, do you see the second one where you put 3.14? And then in parentheses, it's 2.
Yeah, that's what I'm doing.
Okay,
I'm doing that because this is the algebra way to do things. You write
Yeah.
the formula to start, and then you start dropping in the numbers into their place, following the formula exactly the way it was written at top. And so, and then we let order of operation. Once we were down to pure numbers, no letters, then we did order of operation. And then finally we had to divide by 2 because of the type of circle we had. So that's really what we're doing. Yeah. That's the idea. And it's the safest thing to do in algebra because you don't want to have things way over to the right. You want to be, so you can look up. Did I get it? Did I get the right number in? Look up again, look down. It's so easy to mess it up. Okay. Okay, I'm going over here. Okay, 7. The area of a triangle. So this is just that formula we just had a second ago. 1/2 times 19 times 6. Multiply those 3 numbers and you've got your answer. That's the formula for triangle. 1/2 times the base times the height. A swimming pool is 30 feet by 90. Oh. If you, did anybody have trouble with this?
Oh, yeah.
If you surround it by square tiles that are 1 foot. Now here's where the picture will save you. 90 by 30. I'm going to draw it for you. You never see this without the picture. Okay, here's our pool. This was 90. and it was 90 feet. And so each place had a tile that was a foot. Can you visualize it? And so on. Okay, so we put tiles all around. So clearly for this side, we needed 90. And so on this side, that's what they said, they're putting the tiles around the edge. You would need, again, you would need 90. And then this side was 30. So when you started putting the tiles, you would have 30 here and you would have 30 here. Is that clear? So clearly, if you're ordering tiles, you would need two 90s and two 30s. So two 90s is 180 and two 30s is 60. So we're talking 240 tiles. But look here at this corner. Wouldn't you like a tile right there? Tell me now, would you or wouldn't you?
Sure, to complete it.
That would finish it off. My house in Maine was built in 1820. We had to redo every bit of it from top to bottom. I understand looking at things carefully because you don't want to order or you hire somebody. But you see what the problem was, that this is the visualization of it, and you clearly need 240, but guess what? I'd like one for the corner. In fact, I'd like all four corners covered. And I bet you they're gonna like the answer 244. And you would like it visually to finish it off. And I think that's what they wanted. They wanted to surround the pool perfectly. How do you like that? Can you see it now? See, it's the picture that lets you see it.
Well, what kind of a formula would capture it though?
Well, the formula was 2 times the length and 2 times the width to get this.
Mhm.
But then you looked and you just basically had to add in the four corners. And so there's no real formula for that other than just realizing they got missed.
Okay.
So this was the real formula, 2 times the length and 2 times the width to cover the 4 sides. But then doggone, I want to finish that off. I did all that work. Well,
So,
in my case, I hired somebody. But I went and bought those tiles, you know what I'm saying? And so I want them to be able to finish the job, whoever it was.
So the book is gonna say the answer is 244?
I think it's gonna, let's go back.
yeah, I just did mine because I'm like, might as well work smarter.
I know, we're doing work here.
Yeah. Oh, hey, how you doing? Okay. Was looking at myself through myself. Inception. No, but what's it called?
Okay.
So the one I had was 70 both and then 30 both. And it was it ended up being 204. So it's the right.
I just pressed show the answer because my technology is better than yours.
Excuse me.
No, that's right.
What
Give
would
me a
be
break.
indicative?
But can you see it?
Yeah, I can see it.
Yeah, that's the right answer.
My question is, what would be indicative, like, so when the test comes, like, okay, so I see the 30, so do whatever, and then 90 on both sides, but what would like a mental thing for you to tell us, like, there's still 4 sides that you need to add? That's what I wanted,
Well,
like.
you needed to draw it out, and then you might have seen it from that. But in word problems like this, the key ingredient is the part where the question mark is. So when you're trying to sort out what has to happen, look for the question mark. Sometimes there's a couple of sentences, but look for it. And here's what it said. How many tiles are there do you need to surround the pool?
Yeah, I'm gonna be honest with you. I would not have got the final four.
I don't, that's why I wanted to show it to you.
Me
I
either, man.
wouldn't, yeah,
You
and
ain't
I was
alone.
giving you credit for getting the other parts. But can you see now, I mean, you wanted a proper job. This is your house and your pool. You wanted a proper job and you needed 4 more.
Yeah.
Mhm. And so that's the thing. Let me see. Okay. Guess I have to leave the page. I don't know. They're not gonna let me do it.
Yeah, you have to leave the page.
They'll do it, okay. This is number 9. The side of a square is 12 meters. If all 4 sides are increased by 5, how much is the area increased? Let me see our time. Okay. So if you had 12, if the side of the thing was 12 and there, and look at where the question, how much is the area increased? So this is about area. So the original square would be 12 by 12, which is 144 square meters. And so that's the original one. But now I'm going to make another square. And they're adding, what, 5? So what would the side be if they added 5 to the sides? From 12 to 5 more?
15.
To what?
17.
17 it is. So it's 17 by 17. So if you multiply that little that square out, 17 by 17, I think it's 289. Yeah, so that would be 289 square meters, okay? So the area increases, so this is where you'd fill it in, from 144 to 289. So I did it for 12 by 12 and I did it by 17 by 17, which is an increase. Now the word increase means how much did it go up? And so you're forced to subtract the 2 numbers. And I'm getting 145 on this problem. 289 minus 144 would be the number right here. Okay. So this was about area because this whole chapter, a section is about area. Okay, we have one more. The diameter of a $1 coin. Okay, I'm going to write it down. 26.5 millimeters. That's the diameter. I'm going to write it down. Find the area of one side. Wait a minute.
Yeah, I had a lot of problem with that one.
Wait a minute. What are they? Let me read again. Diameter of a $1 coin is this. Oh, find the area. Oh, okay, I just couldn't read it. So the diameter is 26.5. The area is pi r squared. Right?
What they
Oh.
mean,
Remember,
what they
yeah.
mean by one side, since a coin is two-sided, they only want you to find one circle.
Yes, but they should have, I don't know, that phrase one side is throwing things off a little bit. Basically find the area of the face of the coin or something. And so if, and I think I'm gonna draw it and then I think I'm gonna go to the new material. What happened? Share. I want this. Okay. There's our problem. Here's the coin. What they gave us was 26.5 for this diameter. Agreed? But they want the area. And if this is the formula, we do not have the radius. if the diameter is 26.5, the radius would have to be what? See, this is where the picture, what is it?
Radius is half of that.
Yeah, so this is 13.25, and I think I'm going to keep half of 26 is 13, half of 50 is 0.25. So here's, I wouldn't fault you for using a calculator. 3.14 multiplied by 13.5 quantity squared. Because I'm going to use it, I don't want to play this game. 13.25 squared. I've got it to 4 decimal places. Now I'm going to multiply it by 3.14. And my answer is, doggone, 551, 26625. That's the calculator answer. So then you just round it, whatever it said, round it to the nearest unit or to the nearest tenth or whatever. But clearly you had to multiply this first. First we had to half it to get the radius. Then we had to square it, which gave us a number, over 100. And then we multiplied it by 3.14. I did this on the calculator. This is the answer I'm seeing. And I'm sure this has to be rounded. They wouldn't want all of that because that's ridiculous. So, but that's the answer. So the wording was a little bit difficult, but when the whole thing to me is the words are English. Forget English. My best friend at school was a reading teacher. She could do reading and English and I could do math. And so we managed to survive the university. But from my point of view, I wrote down the fact that this was the diameter. I then realized they were interested in the area and I wrote down the formula. And then what I've got left is a picture and a formula. And so I've gotten rid of the English and gone to the math. Do you see what I'm saying?
Yes.
And now
It's
I'm happy. I'm happy over here.
The
with
rounding though, that bugs me.
math is a language. And I said it before, I've been in schools where almost everybody was from a different country, so the English was their second language. But as soon as we got to the math, everybody was happy as a clam. We knew what we were doing. Language or not language. And so you've got to get it out of that sentence into the math so that you can do the problem. Do you hear what I'm saying?
Do you still have the problem up on your sheet?
Well, I would.
The rounding is where it gets me.
Well, and then I really need to go to the next material.
Okay.
Share. I'm going to do that. Round to the nearest hundredth. So 551.266. That would be
27, okay,
27.26.
okay.
Yeah.
I want to
Okay.
make sure.
How's that?
Yep.
All right. So you have a page of perimeter and you have a page of area, and never the twain shall meet, as far as I can tell. So we have, I'm going to take a look at, we skipped 8.3. It's kind of good actually. And we went to 8.4. And I want to visually show you some of these formulas. The first one was a rectangular box. I like that. So the way, this is three-dimensional. There's a length and a width and a height. And the formula is just the three things: length times width times height. And what I want you to see is down here on the bottom was the length and the width. they then did was turn this into, made this the height. So it's almost like they took this thing down here and raised it. And that's where the formula comes from. So this length and width and height. So if this was 3 feet and this was 2 feet and this was 5 feet, let's just say, 3 times 2 is 6, 6 times 5 is 30. But look at how many feet you have. Feet times feet times feet. This is cubic feet. And the things that are measured in cubic feet, the size of a refrigerator is measured in cubic feet. You know, it tells you how much stuff, how much a size will be, so that you know this is the small one, this is the medium one, so on. And so cubic feet, all kinds of things come in cubic feet if it's 3-dimensional. And so the 3 dimensions are the length and the width and the height. And so there's really not a big deal about that. The next formula is this. This is a cylinder. And what I want you to do is see the bottom of it, and I've drawn it as you would look at it. The bottom of it is the circle, pi r squared. The formula for the volume inside this cylinder, all you have to do is include the height. So it really was, this is the circle, which is the bottom, and then it's raised up to the height. And anytime you have volume, you have 3 dimensions, and you have cubic units, cubic feet, cubic inches, cubic yards, cubic miles, whatever. Now, there was a variation to this, which they call the cone. And so so what I want to do is visually, I'm usually better at drawing, but there it is. It's sort of like the cylinder, but here's what happens. With a cone, it goes up to a single point. So what you have is this much. So it really, the formula actually includes pi r squared. It includes the height, and the height would be this much. But if you can see, instead of being the full thing that's in blue, it's not as much, is it? It's almost like they shaved off, like this was ice, and they shaved off a lot of it. Can you see it? In other words, it comes down to nothing right here.
Yes.
And so is it half? No, it's a third. And again, you don't have to memorize it, but here was the circle, pi r squared. Here was the height, which brought it up this high. But when you have the cone, you don't have a full cylinder, and so it's 1/3. And I think you could almost make a case for that. You know, your first guess might have been, well, half of it's gone, so it would have been half. But no, it's actually a third. Okay. Because it went from a complete to nothing, and so you're left with a third. But it's just like plug your numbers in. Once you know it's a cone, that would be the one. And there was one more. It's 3-dimensional sphere. So sphere. And this is basically 3 dimensions. I didn't draw it very well. But there is a radius involved. And so the formula goes, there's the pi, there's the r, and the r is cubed. And the number in front is 4/3. And honestly, I can't make a story to go with that. I could try. The R cubed basically deals with the fact that it's like a ball, it's 3-dimensional. But I would say just write that formula down. The R has to be cubed. So if it was 2, you'd have to go 2 times 2 times 2, which would have been 8. You would still use your pi, and you would still multiply it by the fraction 4/3. So there will be some of those to do. So let's see. So if you had there was a silly problem about an ice cream cone, and I don't know if we're running out of time. So the ice cream cone, which would have been the cone, right? And so if, depending on what they wanted you to do with it, I suspect they wanted you to find the volume. And then to make it interesting, in one case, they put ice cream in it.
I have a screenshot of that problem. Do you want me to read it to you? I had a lot of trouble with that problem. Do you have time?
Yes, and
I can read you the, do
yeah,
you mind?
yeah, let's do it.
Okay, thank you. I just could not.
I know.
Okay,
Yeah.
okay. An ice cream cone has a radius of 2.2 centimeters and a height of 6.4 centimeters.
Okay.
The cone is filled with ice cream and one additional scoop in the shape of a sphere with the same radius as the cone is placed on top. What is the amount of ice cream in cubic centimeters? Round. I know.
It's
I
the
round to
worst
the nearest
one.
hundredth.
Yeah. So I heard that the ice cream cone, the ice cream could be considered a sphere.
Yes.
Okay. So
With the same radius as the cone. Okay.
yes. So so here's our formula.
Okay.
And I'm just gonna bring it down here because I have my picture. Can you see? This is maybe let's make it.
Yes, that's great.
Need more ice cream. So so we're interested in the formula for sphere. That would be 4/3 times 3.14. And the radius, the fact that they told you the height of that, I don't think makes a bit of difference. But I do think the radius does matter. It's part of the formula. And so the radius would be 2.2, and it is centimeters. And that needs to be cubed according to the formula. So we're going to try this. And of course, I'm going to try it with my calculator because I have no use for doing it by hand. The first thing I would do is take 2.2 and cube it. I've got 10 point something. I'm then going to multiply it by 3.14. And I've got 33 something. And now I'll write that in. What my calculator, 33,43472. 7, 4, oops, 43, 472. Now I need to multiply it by 4/3. So I did this in order of operation, and depending on your calculator, this is the safest way to go. 2 times 2, 2 times 2 to the 2.2 to the third power. And you can use this key if you have it, or whatever, or just multiply it 3 times, 2.2, 2.2, 2.2. Regardless, get an answer, multiply it by 3.14, and this is the answer I saw. And then you still need to multiply it by 4/3. I think what I would do, I still have this in my calculator, this number. I I think I'd multiply it by 3. No, I'm sorry. I don't want 3, I want 4. And then take that answer and divide it by 3. So it's really 4 times this number. And then once I had that, I would divide it by 3. And let's see what I have for an answer. 44.57, 44.5796, whatever. And I imagine they want it rounded. Did they? I mean, really, how much, how accurate do you need?
Rounded to the nearest hundredth, so 0.58. But okay,
And it would
I
be,
just couldn't.
yeah, centimeters cubed because everything was in centimeters. So when you did the centimeters cubed here, this is where it took on its cube.
Mhm.
What do you think?
Yeah,
So it was really about a sphere. And so the
Yeah.
sentence that usually it has a question mark, not always, but usually it has a question mark. Find the area of the ice cream, which is a sphere. And then you said, forget the cone.
yeah,
Just going to eat it nicely and the only thing about the cone was they told you the radius,
yeah.
which, you'd be forced to, it's hard to make it more than that. So that makes sense.
I overthought it.
Okay.
I made it, I overcomplicated it. So thank you.
Okay. Well, I thought we were going to have to do something with the cone as well, and that would have been really a lot. So that's actually all there is. Occasionally you have to use some of these formulas. Length times width times height is really important if you're, doing packages. Sometimes, the post office will say, well, wait a minute, and then you notice how sometimes they'll measure the package just to make sure it's sort of fitting their idea of what's right.
Is it possible to take a quick look at the coursework examples of 8.4?
So where do you want me to be? So I'm getting out of this and I'm going to, what do you want me to do?
8.4, the examples they give for the course.
For the book?
You're right. Examples
Okay,
2 and
you're gonna have to help me get there.
uh,
First of all, I'm gonna
yeah.
to this. Now, this is where I got into trouble yesterday. So
So you're gonna go to,
let me think if I can remember.
yeah.
I want to go here, don't I?
Yeah, I'm not sure the ebook is the same, but let's see.
Yeah, okay. And the
Should be the-
contents. I
right.
read that, and it's chapter 8, and it's 8.4.
Right.
And they make me sign in like I'm illegal. Okay.
Okay, so numbers 2 and 3, there's an exponent discrepancy. So
This-
right there under the straw, they have the 0.125 with the exponent outside of the parentheses.
Typically.
And then number 3, they have it inside the parentheses.
That that number, which was 1.125,
Yes.
that is correct to put the exponent on the outside. And then once you squared it, because you did that first, then you got this number 015625. Then once that's done, they're not using the units until the very end. They're just dropping it in cubic inches. So they could have included the unit here on the second line, but they just waited till the end, knowing that because it was volume, they said cubic inches at the end.
Okay, if you scroll down to number 3.
Yeah, let's do it.
And then they have So with that
Mhm.
cylinder, they have the, let's see here. Okay, so under the volume 1/3 under the second cylinder, they have it inside the parentheses.
Okay,
Trying to see if there's a difference there or not.
the 1/3, 3.14. Yeah, darn them.
Yeah.
That does get confusing.
But that actually, in that case, it's this, if it's a positive number, which these are because they're measurements, it
Mhm.
actually doesn't matter whether the square is on the inside or the outside. If the number was a negative number in a different type of problem, it would
Mhm.
make a difference.
Okay, because earlier chapters say there was a difference if it was in or out.
It could be, there could definitely be. And I think in general, putting it on the outside is the safest move because then it works for whatever kind of crazy problem might come up. So,
Right.
so the parentheses, in my opinion, would have the 3 in the parentheses and the square on the outside. I
Okay.
think the other one was a better. Were there any questions? In this case, it didn't matter, and so they got a little, they're not consistent. They weren't consistent there.
Mhm.
So then they took it to 9, and that's what they had to do. Was there any other questions there, or was that it?
Oh no, with that 9 that you just mentioned, so they multiplied the 9 to the 1/3 and got 3 below.
Do you remember how I said I like doing, I like taking the easy road if I can? When I'm on this line here, which is the second line, and I saw 1/3, and I saw a 9, and I knew that a 3rd times a 9 is 3, I would have done the same thing. Because there's 1, 2, 3, 4 numbers to multiply. So if you can do anything easy, I mean, that's the training. And then most people that are over a certain age, like me, we had to learn to do things without calculators.
Right.
So you just never took the hard road. Do you understand what I'm saying?
Yeah.
And so your training, when you had to do so many thousands of these, you would see a 3rd, you'd see a 9, and you'd say, darn, I'm going to grab those 2. And then I'm left with the 3.14, the result of a 1/3 of 9, which is 3, and then the 5. I do that all the time. And, it just depends on the age of the person writing the book.
Mhm.
And you saw his age, he looked like me. Right?
So you also could have done the 5 as well, but it's easier to do the 9 in this case.
Yeah, a 1/3. Yeah, see, because the 1/3 of 3.14 is not easy. A 1/3 of 5 is not easy, but a 1/3 of 9. And see, they're forgetting that this is a different generation. Although the times that you take shortcuts that save you time and effort,
Mhm.
it's sort of like a safety thing in a way, because the fewer calculations that you have to run through, the safer you are that
True.
you'll get the right answer in the end.
Okay.
Yeah, and notice how even here on the 3rd line, they did the 3 times 5 first. They saved that 3.5
Oh yes,
for
yes.
last.
Mhm.
What it
Yeah.
amounted to. They
Okay.
didn't want to do that. So they saved it for last. I hope that makes sense to you.
Yeah, it does. Thank you.
Yeah. It's an age thing, doggone.
Professor Patterson, is it okay if, because I don't want to waste your time, any of your time beyond this class, and I have another class, but there were like two problems in 8.4 that I just had some questions on. Can I just send them to you in a message? Is that okay?
Okay, do that. That would be fine. Most of the time I
Okay.
can explain it well enough. I'm gonna
Okay.
curtail
And
our-
can I just real quick though, can I just ask you, is volume similar to area, where if you have a multi like you have, because a lot of the problems in 8.4 were not just a simple structure, but like, let's say instead of just a rectangle, it was like a stair step. And then, so then you're given like multiple numbers. So are you supposed to figure out what they haven't given you, or is it similar to area where you just take what they've given you? Does that make sense?
Well, hopefully, one part I thought you were asking about had to do with, are you adding up the pieces?
Yes, that's perimeter more, right?
But no, it could,
No. Okay,
even with area, where we had like a strange shape, but it
Mhm.
amounted to two rectangles,
okay,
you would add the two areas. That's what we did
Okay.
earlier. In this
okay,
case, if you're in 3 dimensions, which is what you are when you do volume, there's a length,
right,
a width, and a height involved.
yeah,
You would add the pieces.
okay,
So for instance, this one here, you would have to add the cylinder, like that's all you had. And then
right,
let's say you needed to add half of this sphere. You
okay,
would then, in the end, it looks like they've added the two.
okay, okay. So
And
if
so
it's like
that's-
3 rectangles, like a stair step, it's like 3 rectangles, you would have to do the same. Okay,
You're just adding, and just be sure which dimension you're in, because perimeter
okay.
is 1-dimensional and area is all 2, square
And then,
stuff. And this
and
is
then
all
3 for
3.
volume.
Because
Okay,
it's
that's
enough to
okay.
get all 3.
Okay, I'll try it on my own first, and then if I can't figure it out, I'll send you a message.
Okay, good enough.
Thank you.
All right, I'm gonna do something with this if I can figure it